One day, when I was playing with colorful toy spring, I deeply wondered why it behaves in this manner. It stretches and compresses. As a student with a curious mind, I started reading a textbook to discover the answer to the question I have in mind. Eventually, I came up with an answer. It is a real eureka moment. So now, the answer lies within a law created by an English physicist, Robert Hooke. The law states that the displacement of temporary distortion of any elastic object is directly proportional to the force applied. Conversely, force applied causes an elastic object to be displaced. It is to be stretched or compressed. This law applies to a spring since it is an elastic object. Commonly, this law is written and stated as a mathematical equation, but don't worry, we will not dive into math deeply. F equals Ks, where F is the force applied, K is the force or spring constant, and S is the displacement from rest position. K is a constant that defines the amount of force needed to displace an elastic object a unit distance. The law then implies that if the force applied gets bigger and bigger, the displacements gets bigger and bigger as well. Similarly, if the force applied gets smaller and smaller, the displacement gets smaller and smaller too. It is important to note that a push or a pull causes the spring to be displaced, compressed or stretched, respectively. However, it is important to remember that Hooke's law will only be true for a certain range of force applied to any elastic object. In our case, the spring. What does this mean?
Well, it only says if a very strong force is applied, it may cause permanent deformation or distortion to the spring. When this happens, the Hooke's law no longer applies.